Hello, this is Vishnu Atriya here, and today I'm going to be taking a class on MERGE-Stack. Specifically in MERGE-Stack, we're going to be discussing APIs, and in APIs, specifically REST API. So, during our journey of web development, we first learned about HTML, then we've learned about CSS, then we've learned about JavaScript, and now we've come to MERGE-Stack. Now, let's just start off with MERGE-Stack. MERGE-Stack, as the name suggests, has 4 letters present. The 4 letters are M, E, R, and N. The M stands for MongoDB. This is your database component. The E stands for Express.js. This is some sort of a middleware that helps connect your server to the database to make any changes required in that component. Next, we have R, which stands for React.js. This is where your front end and your front end frameworks, all the UI is taken care of with React.js. And next, we have N, which stands for Node.js, which is the language used to, which is the framework used to write all of this. Now that we've got that out of our way, let's move towards APIs and what APIs are. So what is an API? What is the full form of API? So what is an API? What is the full form of API? So an API, it stands for Application Programming Interface. If we define this formally, it's a set of rules, protocols, and tools that help different software to communicate with each other. Now I'm sure all of you have used apps like Swiggy, Zomato, Ola, Uber countless times in your daily lives. One thing that you may or may not have observed is the usage of APIs in all of these apps. Now, when you place an order in Zomato, you enter your delivery address and there's a pickup address where the order has been made. This is the restaurant's pickup address. You have noticed that the delivery boy knows exactly which route to take and reach your house, and there is a time duration that shows how much time away the delivery boy is. The reason Zomato is able to do this with utmost accuracy is because they use the Google Maps API. Now think of it from Zomato's perspective. When you place an order, if they have to map out every restaurant and map the distance from your house, that is a very huge financial task, and it's also something Zomato is not good at. Zomato is good at helping orders, it's good at helping restaurants make revenue and helping you to get food where you're sitting at. Its job is not to make maps. So what did Google Maps do? Google Maps made a Google Maps API and told all these apps to to send a request to Google Maps saying I need the following data. Now all these apps, Zomato, Ola, Uber, have some sort of authentication built. This is in the form of API keys. Now say the API keys can colloquially be referred to as a password. So it's a 16 digit string involving special characters, characters from A to Z, capital A to capital Z. This is at, comma, full stop, etc. and numbers. Now this API key should match the API key given from Google Maps. If both of them match, if there is a handshake that happens between them, Google Maps sends a response to the request sent by Zomato. Similarly, in Ola, when you click on your drop location, say your drop location is India Gate. The India Gate has a specific coordinate, has a specific set of coordinates that pinpoints to it, and this is present in Google Map. Now, from the Uber app, if I send a request saying I want the exact location of India Gate, Google Maps will send back a response which gives me the location of India Gate, from where I will enter that as my drop location, and then we end up moving, and then the driver knows that the endpoint has to be India Gate. This is how Google Maps has its API inbuilt into a lot of these apps, which make our lives a lot easier, as you can notice every single day. Now, an API can be considered as a bridge between two software systems. You have your Olas, Ubers, Swiggy, Zomato, anybody who needs the Google Maps API on one side and the Google Maps API on the other. This main bridge, how do you authenticate the request? The request is authenticated or validated with the help of an API key. So the API key that is present over here should be the same API key present over here, which is when for a request sent, we will get a response. That is how APIs work. Now there are a few examples of APIs. One is Web API, next is Operating System API, next is Library API, then there are third-party API. The APIs that I've been talking about so far, such as Google Maps, WhatsApp, etc., are all third-party API. Web APIs are used for communication between web servers and clients. So say there's a web server located somewhere remote, and there is one guy who pings from say Singapore, there's one guy who pings from say Delhi. So he sends a request to the web API, to the web server saying I need the total number of counts of number of users logged on, and say there are 1500 users. So if the request gets matched, it sends the required response back to it. Similarly, the one in Singapore will send it a request saying tell me the number of male users accessing it. So out of 1500, say 700 are male. So if the keys match, then it sends a response. Next is Operating System API. Operating System APIs are things that allow apps to interact in the system with each other. Now, library APIs are where developers create libraries of code that fellow developers can use without understanding what the whole library ends up doing. So as you know, while developing with JavaScript, we have a lot of libraries. Say for MongoDB, we have to use Mongoose. We use Express.js as a library. We use Body Parser as a library. We use Axios as a library. Now all these libraries are locally installed in our node modules, but there may be cases where we access all of these using an API. Apologize me for the bad handwriting. I'm pretty sure I'll work on it and try to improve it. Now one main type of API that we're going to be discussing today is called the REST API. The word REST stands for Representational State Transfer, and API stands for Application Programming Interface. What exactly is a REST API? So REST API is a type of a web API that follows a set of architectural principles and constraints while you designing networked applications. This uses the HTTP protocol, which I think you have studied about in either the HTML part of web dev or during the JavaScript part. It uses the HTTP protocol to interact between your client and your database. So there's a server in the middle. This is your client. There is a server which can be remote or local or anything, and this is your database. Now let's think about a simple example. Say you run an ice cream shop. Now in your ice cream shop, let's think of the simplest example. Your database is in a MongoDB. So as you know, in MongoDB collections, every single entry has an ID associated with it. So say ID 1, 2, 3, 4. Your second column is flavors of ice cream. And the next is how much quantity. This is for your inventory management. So say you have chocolate present, you have 500 of chocolate. You have lychee, you have 650 of lychee. You have strawberry, 200, and you have black forest, you have 340 or whatever, and so on. You have multiple flavors and you have multiple quantities as well. Now every single time you want to add a new flavor or modify the quantity or delete a flavor, you can't be interacting with the database, and it's not necessary for the person who's working in the cashier to know how to interact with the database. Specifically, there are only 4 operations that you would perform in a great database. Those are called as CRUD operations. So if we see what these are, C stands for create. This involves creating a new entry. R stands for read. This is printing whatever is already exists. U stands for updating, where you will update based on an ID, so that the database knows which entry it has to update. So this is the ID that is going to be used. And D stands for delete. Again, delete is based on ID. Or you can delete the all records together, but that usually serves no purpose. So delete is going to be based on an ID. Now, to perform these operations, a user can definitely go into the database directly and modify the entries using the MongoDB UI or using MongoDB commands. But that serves very little purpose, since the person has to be able to do it without accessing the database entirely. That is where REST API comes. So REST API is written in a format such that there is a client present, there is a server, and there is your database. You have all your entries present in this. Now the person sends a request. Requests are of 4 types. I will get to them specifically. The request gets passed on to the the request gets passed on to the server. The operation is performed, and then in response you get the product whatever is required, and that is relayed back to the client. Now these requests are of many types. There are about 6 types of requests, but we will focus on only 4 types of request. They are get, post, put, and delete. Now get, as the name suggests, is where you fetch the results, is where you get the results. This can be done with ID or without ID. Post is adding a new entry. In terms of post, you have to provide an input which will be provided in the JSON format. So you will have curly braces with each entity name and your each entity quantity, comma, each entity name quantity, and it will be passed in a JSON format. Now this can either happen in JSON format or in XML format depending on the client. Next you have the put method. The put method is to update existing entities based on their ID. Fourth is the delete method. As I explained earlier, delete and delete, they're the same. It's to remove an entry. Some key features of REST API is that it is stateless in nature. What does stateless mean? Stateless means that each request from a client to a server must contain all the information required to understand and fulfill the request. If incomplete information is provided, then the request will not be processed. I'll show you that. So I have written a small program to demonstrate the same. I will go through it and explain it to you in detail once I just go through the concepts of REST API in theory. There is no session state stored between requests. So as you may all know that phones have a cache memory as a temporary memory where it stores some of the data to fetch it back later if required. This does not have any cache or anything of that sort. It sends, if you've not provided all your information, the request shall not be processed. If you provided all your information, then the request shall be processed immediately without it being stored anywhere. Now, a REST API has layered system. It can compose of multiple layers with each layer having a specific responsibility. Layers can be defined as controllers, routers, middleware, etc., etc. So the more complicated your project is, the more collections you have, the more complex it is. It makes sense for dividing files accordingly, so it becomes easier for you to track your code later on. Then representation. Resources can have multiple representation. They can be in JSON or XML format. I've mentioned it over here. Now let's look at some code that has been written. So now so this is a code. It's an app.js function where I have 4 methods. So there's a get method which tells me the API has been activated. There's a get method getting all the flavors present. There's a post method to add new flavors. There's a delete method to delete flavors by ID. And there's a method to update an ice cream flavor by ID. Now first thing we have to do is start the server. When we start a server locally, we're going to be doing node app.js is the file name. We can see over here that server is running on port 3000 and it is connected to MongoDB. Now let me just show you the other window where all the requests shall be captured. Now this software is called Postman. Postman is specifically used to interact with API, test APIs and make sure that they're all working accordingly. Here you can define your methods: get, put, post, patch, delete, head, options. There's about 6 to 7. You can define your own method. You can type your own method if you need, but we are going to be focusing only on the pre-written methods that are get, post, put and delete. Get. Now you have to understand that because it's started locally on port number 3000, HTTP. REST API works on HTTP protocol, localhost port number, and this is our entry point into the API. Flavors. We can see in our code, if we can see, I'll just try showing both of them side by side. Yeah, so if we can see over here, this is our first entry point. If we just do localhost 3000, we're going to get hello ice cream API. So let me just switch on my browser and show that to you guys. Window capture. So localhost 3000 hello ice cream API. So just going over here shows me that my API has been activated, server is working. Now if I go to Postman, so you can see Postman on your top, on your right bottom, and you can see VS Code occupying major portion of your screen. I'll just maximize Postman right now. So one second, there's a slight error over here. Yeah, it's much better now. Alright, so if we go to Postman and go to get flavors and I click on send, it sends a request. You can see over here that in JSON format I have name of the flavor and quantity of the flavor, and there's an ID attached with each of those. So you can see there's 10 chocolate, 12 strawberries, 8 mint choco chip, 7 cookies and cream, and 2 red velvet. Now I'll go to the post method, just re-verify that the endpoint is the same. Yes, it is the same. Go to body and I will type my input in JSON format. So say I have banana as a flavor, and as you know, REST API is stateless in nature. So you guys can notice that quantity hasn't been mentioned over here. If I click on send now, name and quantity are required, an error gets thrown. So I understand my mistake, and now I enter quantity as 15. And if I send it now, you can see that ice cream flavor has been added successfully. Now if I go to get and view again, you can see that banana and quantity 15 has been added. Now to demonstrate put method. Put method needs an ID. So this ID is what we're going to be considering. So now I put the ID over here, and instead of 15, I want to add 10 more. So say 25. If I click on send, you can see that the quantity has been updated. Name still remains the same, and this is matched by keeping ID as your primary key. Now the last method I want to be able to demonstrate is delete. So again, for deletion, I'll use this ID itself. And if I wait, I'll just modify the ID once to show you that errors also do arise. Now this is an ID that doesn't exist. If I click on send, it says flavor not found. So let me just go to get and just show you bananas, and we'll just go to that ID. Banana, I'll just copy the ID, slash with the ID, go to delete, and then send. Ice cream flavor deleted successfully. Now if I go to get and view my, notice that I'm removing the IDs each time I click on get, because this is not get by ID. We've defined only get all ice creams at one shot as a function. So you can see that all flavors exist with no changes to them. Now this is a MERN-stack REST API I've written. So this is hosted on MongoDB. Hence you can see there's an ID field for every single entry that is present. Now in case I was using another database, say MySQL, the architecture, not the architecture, the way the program would have been written would be a little different, but fundamentally all concepts remain the same. So that's it for today, guys. Thank you for listening through my explanation. I hope I've been able to teach you something. Do tell me if there's any improvements I have to make. One for sure is handwriting. And yeah, that's it for now. Thank you very much. See you in the next class.